Hello everyone. In this video, we're going to be solving a Diophantine equation. In other words, an equation with integer solutions. So m and n are integers, and we're going to solve this equation. M squared minus n squared equals 2m plus 4n plus 74. Now, this expression kind of reminds me to use difference of two squares because I have m squared minus n squared on the left-hand side. Is that going to be helpful? I don't think so. So let's go ahead and do this a little differently. I want to put everything on the same side. And maybe leave the 74 on the right-hand side for now. What I'd like to do is turn this into a difference of two squares, but with everything involved except for the constant. So how can I do that? I can put these together and then kind of separate these. And now I'm thinking to make this a perfect square, m squared minus 2m, I need to add 1. So let's go ahead and add 1. That's going to make it m minus 1 quantity squared, right? And then for n squared and 4n, I do need a 4 because remember the rule is you take the coefficient of n and then cut it in half and square. So half of 4 is 2, 2 squared is 4. So you do need a 4, but you have to be careful. This is a minus sign, this is a minus sign, so you need another number with the minus sign. So it's going to look like this. I need to subtract 4. But what I did was I added 1 and subtracted 4. So it's equivalent to subtracting 3. So I have to do the same thing on the right-hand side. Make sense? So 1 minus 4 is equivalent to negative 3, so I had to subtract 3 from both sides, and I did. Now, let's see how this plays out. This gives me m minus 1 squared. And this expression inside the parentheses, because if you take the negative out, you're basically negating everything inside the parentheses. That gives you n plus 2 squared. And 74 minus 3 is 71. And guess what? 71 is a prime number. Awesome, right? So here's what's going to happen. We're going to factor this using difference of two squares. So if you call this a and you call this b, that's going to be like a squared minus b squared, and that can be factored as a plus b times a minus b. All right, one of my favorite formulas. Now let's go ahead and apply the formula. A plus b times a minus b. And when you minus b, you're going to basically negate n plus 2. So it's going to be the opposite of n plus 2. All right? And this is equal to 71. Great. So we got ourselves a nice product. And if you're solving an equation with integer solutions, it's important to get a product because you can basically talk about, okay, what numbers can go into 71, what are factors, what are divisors, so on and so forth, right? This is a product, and since m and n are integers, these are also integers. Make sense? So we want two integers whose product is 71, and those are these numbers. So let's go ahead and simplify this a little bit. I get m plus n plus 1, which is the first factor, and then the other one is going to be m minus n minus 3. And this product is equal to 71. Awesome. After a little bit of algebraic manipulation, we were able to get it down to this point. Now, this is good. Now, we're going to think about factors of 71. Right? 71 is prime, so there are only so many factors that you can look at. For example, this can be 71 and this can be 1. Or it could be the other way around, like 1 and 71. Those are pretty much all the positive choices. And then you need to look at the negative 71 with negative 1, and then negative 1 with negative 71. Those are going to be the only choices, including the negatives. There are only 4 ways to factor. So let's go ahead and take a look at each one. M plus n plus 1 is 71. That means m plus 1 is 70. And m minus n is 4, right? Because minus 3 equals 1. And from here, we can basically add these two up and then divide by 2. 2m is 74, m is 37, and n is 33. That gives us one of the ordered pairs. Let's continue. The second one is going to be m plus n equals 0 and m minus n equals 74. This sum is not going to change. Basically, the m value is going to stay the same, but the n value is going to be different. And that's going to be basically negative 37 because their sum is supposed to be 0. Make sense? And then we're going to look at the other cases, m plus n. Now notice that the first one adds 1, so I just need to subtract 1 from this and add 3 to this. Okay, so minus 1 here and plus 3 here. Remember that. Minus 1 plus 3. Okay, minus 1 and plus 3. Okay, so those are going to be my numbers. And then if you go ahead and solve this system, again, add them up and divide by 2, m is going to be negative 70 divided by 2, negative 35. And then n, you can also find n differently, like by subtracting these two and divide by 2. That's going to be negative 37. Make sense? And then let's go ahead and take a look at the last case scenario here, and then we'll finish up. So the last one is, again, minus 1 plus 3. Minus 1 is going to give you negative 2. And then plus 3 is going to give you negative 68. Make sense? Okay. Negative 68. From here, again, these two are going to cancel out. 2m is going to be negative 70. M is going to be negative 35. And to subtract and find the answer, that's going to give you 66 divided by 2. And it's going to be 33. Let's go ahead and list all these solutions as ordered pairs, m comma n. It's going to be 37 comma 33. And then it's going to be 37 and negative 37. And then we have negative 35 and negative 37. And we have negative 35 and 33. Is there some type of symmetry? Well, looks like when m is 37, there are two values, different values, and when m is negative 35, so there are two different values for m and two different values for n. That gives us 4 possible ordered pairs. But you can always check your work. I mean, you don't have to, but if you have time left, what if you made a mistake, right? So you can go ahead and write this as m squared minus n squared, the original problem, 2m plus 4n plus 74. Now let's just go ahead and take a couple of these. Maybe the positive one is probably an easier version. Let's go ahead and plug in 37 and 33. 37 squared minus 33 squared. Is that equal to, I don't know yet, right? 2 times 37 plus 4 times 33 plus 74. Now take a look at this. You don't have to evaluate 37 squared. You can just use difference of 2 squares here. That's okay to do. And you can write it like this. This is going to give you 70 times 4, which is actually going to be 280. Okay, let's take a look at this one. This is going to be 74. This is going to be 132, and this is going to be 74. If you double 74, you're going to get 148. And if you add 148 and 132, you're going to get 280. So these two expressions are equal, which means our first ordered pair checks. Obviously, you may want to check all of them, but at least the first one is correct. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.